You want to be in my thumbnail? Yeah. Oh, well, it's too late now. But you come on up tomorrow. I'll let you be in the thumbnail. Huh? Does anybody ever? No, we already started. Does anybody look at the thumbnails? Nope. That's what I thought. All right. So let's see here. All right. So this is going to be 4.1, which is exponential functions.
Yeah, no, so much.
So did I tell you guys that this class gets harder the longer it goes?
Yeah.
So all the people that leave, I don't know what you're thinking, okay? Sure, some of you have to work, but gosh, it's tough to take a class when you can't see what's going on. All right, so what if I told you to graph? Well, I'm really glad I brought all of my colors today because we're going to use them. Half of x equals 3 to the x. Okay? Now, Dino, you don't know how to graph something. What always works? Plugging stuff in, right? So let's just go ahead and we'll do an XY table. What are some good numbers to pick?
0.
0 is a good one. What else? 0, 1, 2, 3. Let's pick -1 and -2. Okay, let's get some good ones. Okay?
X exponent?
X is the exponent. Okay, that's why we call them exponential functions. Okay? All right, so Dino, what is 3 to the 0 power? And please don't get this wrong. 1, very good, thank you. I was afraid you were going to say 0, and I was going to feel bad. 3 to the first power. 3. 3 to the second power. 9. Let's not do 3 to the third. 3 to the third, do you know that one? It's 27. 3 to the -1 power. That's a tricky one. 1/3, very good. 3 to the second power. 1/9, is that what you said? Talking way too soft.
Scary.
Okay? All right, so let's go ahead and graph what we've got. 0, 1.
Your x value
1,
is wrong.
1, 2, 3.
It should be -2.
Oh, sorry, -2. Yes, thank you. 3 squared. 3, 1, 2. Wait, 1, 2, 3. I'll put that in the wrong spot. 4, 5, 6, 7, 8, 9. 3 to the -1 power is 1/3. -2 is 1/9. Do you think we're ever going to cross that? No, we're not. Okay? So I'm going to asymptote that goes right there. Okay? So as we look at this, it's going to go here. Okay? 3 to any negative power still is not going to go below 0, correct?
Yeah.
Okay? All right, now let's do, just for fun.
So say it was like 3 to like the -20, would this be like barely touching the
Barely
edge?
above there.
Barely, like microscopic?
Microscopically.
How about 3 to -4 or -400?
Yes, even more
That's
microscopically.
crazy.
Okay? 3 to the -1,000,000th.
You can look at a microscope.
You won't be able to distinguish it. Okay, let's do, what if we did? I'm trying to decide what I want to do here. The book has 1/3 to the x. Okay. Do you realize that can also be written as 3 to the -x? Same thing. It's probably easier to do it this way though, right?
Right.
We're going to do the same thing, the XY table. Spencer, what numbers do you think I should pick?
Our basic.
How about the same ones?
Yeah, that's fine.
So
0, 1, 2, 3, -1, -2. 1/3 to the 0 power is?
What?
1.
That one.
1/3 the first.
Third.
1/3.
1/3. 1/3 the second power.
1/9.
1/9. 1/27. 1/3 to the minus 1 power. 3. 3. 1/3 to the minus 2. 9. Okay. All right. So 0, 1. Okay. 1, 1/3. 2, 1/9. -1, 3. And -2, 9. So if we draw this in here, what did we just draw?
Does that be considered the inverse?
That would be the mirror image. Okay? Not the inverse. Okay? Now, so here are some key points. We want to do some more of these. We'll do one more before I do these key points. What if I said, in green, f of x equals, let's go with 4. 4 to the x power. Andrew, what do you think? What are some good points to pick?
0, 1, 2, 3, -1, -2.
And I'm gonna pass it to someone else.
That's the me.
No, I didn't give you that option there. 4 to the 0 power is?
0, 1.
Man, I know I'd catch up somebody. It's 1.
But don't worry about it.
4 to the first power.
4.
4 squared.
16.
16. I won't make you do 4 to the third, but it is 64. 4 to the minus 1.
1/4.
1/4. 4 to the minus 2.
1.
1/16. Okay, so let's do this. Now, what do you notice? That every time it goes to the same point, right?
0, 1.
So it always goes through 0, 1. Okay. 1, 1, 2, 3, 4. 2, 16. That's 9, 10, 12, 13, 14, 15, 16. We're all the way up here. I'm not going to do the next one because it's off the board. -1.
Like off the chart.
1/4 is here. Okay, so here we go. Good thing I brought my colors today. Okay?
So the higher the number.
Yeah, we
the more
refer to this as
skinnier
the
it is,
base,
kind of.
and this is the exponent.
So the higher the base, the more
The higher the
skinny-
base, the steeper it gets,
steeper.
right?
More
Okay. Now, so some key things to remember. Key things. Okay?
This way faster.
It always goes through, key things, maybe I should say exponents. Always goes through 0, 1, and I always have an asymptote where?
0. X or
What equals 0?
X equals 0.
Nope.
Y equals 0.
Y equals 0, okay? So those are some key things to remember. So yes.
What if it's 4 to the x minus 1?
We'll talk about that. We're going there, okay? So I'm just talking about an unshifted function. And maybe I should say unshifted. Okay?
Quick
Yes.
question.
So on the asymptote, it says y equals 0, minus y equals 0.
Because
You'll never pass it.
Asymptote is
this is
0.
y equals 1, y equals 2, 3, 4, 5, right? So y equals 0, that's where your asymptote's on the x-axis.
So the y asymptote's on the x-axis.
Yes, and that's where y equals 0.
Okay.
Okay?
Gotcha.
Oh, we were barely on the screen there. I didn't even notice that. I guess we didn't miss anything. All right. So now
It's colored.
we want to answer Angel's question. Now I'm going to pick another color. What's that? We don't have to answer it. Okay. So if we were to graph g of x equals 1 plus 2 to the x. What do you think that would do to it, Angel? Or maybe instead of putting it there, I should write it as 2 to the x plus 1. Would that be helpful?
Yeah, 2 to the x plus 1 or 2 to the, that would just,
Which way would it shift? Up, down, left, or right?
to the right.
Okay. Are you sure?
No.
No? Okay.
Kind of shifted up one.
Should we do the XY table and see what happens to it?
Yeah.
Okay, let's do the XY table. XY, 0, 1, 2, negative 1, negative 2. Okay? 2 to the 0 power is 1 plus 1 is 2. 2 to the first power. 2 plus 1, 2 squared. 4 plus 1, 5. 2 to the minus 1 power.
Negative 3.5. Oh, shit.
1/2. 1/2 plus 1,
1.5.
1.5. 2 to the minus 2. 1/4. So this becomes 1 1/4, correct? Okay, so let's go back to here and let's see what happens. Okay, so I've got 0, 2. All right, now, is that good enough information to say what happens to my thing? It's not? Okay, what if I go to 1, 3? 1, 2, 3. Okay. 2, 5, 2, 3, 4, 5. So 2, 5. Is that right? I don't think I have a very good scale on here. Negative 1, 1.5. It's going to be about right here. And 1 1/4. Oh, sorry, 1 1/4 is right there. Okay. So that's enough information, right?
Yep.
Now what happens?
You got
What do you think my asymptote is?
Probably shifted up.
It's probably shifted up one, that's correct. So this becomes my asymptote here.
so now down there past.
Okay, so unshifted, we go through 0, 1. If you add 1, does it shift it up, down, left, or right?
Up.
So it's going to shift it up. If I had a minus 1, it would shift it
Down.
down. Okay? So now, so one way to think about this, okay? We know, I'm going to give you a general form. Y equals some value a to the x power. Okay? So normally we would have here and we would have this point and it would go like this. Okay? Now the question is, let's assume that a is a whole number. So a equals a positive whole number. Okay? Now if I add a plus b and a plus, maybe I should see if I matched the book. Because I think they tell you this.
Would you shift it left or right based off your B? Yes.
Yes, the positive B is going to go left, whatever B is.
Well, they don't give you a nice summary here. So I can use
So like
whatever letters I
X
want.
plus B.
Okay, plus C. Okay.
Should we put a value in front of x?
And graph it.
It was like 3x, a to the 3x.
Yeah. With that.
You want to put a value in front?
Amorphous? Not amorphous.
D. Okay, I'll put a D there.
It's like
Oh, no,
a
It's
D.
going to
So-
affect the size of
If
the.
x was to be like 2x, or,
Oh, and E.
No, I need the B and the C just
Yeah, right
where the graph is.
Yeah.
The B will change.
All right. So let's assume that A is a positive whole number. Okay.
The D was change the graph, the B and the C was change the location.
A positive, okay, so A is going to be a positive whole number. What do you think that the B does to it?
It's going to shift it
Left or right.
left or right. If it's
Okay.
positive, it's going left.
Positive is going to be left. Negative is going to be right. Probably should use red, huh? We got one more
You're
color
off
here.
the. off the
If
screen.
the letter C, positive is going to be
Upper,
up, negative is going to be down. What's the letter D going to do to it?
It's gonna affect the size. It's gonna make it thinner or larger, right?
It's gonna change the actual graph.
Well, let's talk about positive and negative. So if it's positive, a positive D, it's going to make it steeper faster. What's the negative going to do to me?
It's gonna make it fat,
Make it longer, I guess we'll say.
wider.
No, it's going to flip
Oh, yeah. You're right.
over the asymptote. Okay, and then in this case, the E, what does the E do if it's positive versus negative?
I have no idea. If it's
Positive is normal, right? Positive is normal. What did negative do when I did it over here? It's gonna flip it over
The y-axis, right?
the y-axis.
It's a good question.
Okay?
So say we have on the
Crazy here.
on the first one, say it was f of x equal to -3. Would you just, we said to flip it over the asymptote, would be like, so it's right here, right now. Would it be like this? Like flipped over?
Let's do an example.
I'm down.
Let's go,
Let's do
f of x equals negative
-3.
2
Okay.
times 3 to the 4th x plus 5 minus 6.
You can do it. I believe in us.
Okay? Can we see that on this video?
No, you can't.
Yeah, we got it. We're good.
Oh, yeah, we do.
Okay? So let's talk about the unshifted thing first. Where do we start?
0, 1.
We're going to start at 0, 1. And I've got an asymptote that goes here, correct? Okay. What is this first negative going to do to me?
Flip it, so it's gonna be.
It's going to flip it underneath, right? And instead, so normally it'll flip it here, okay? What's the 2 going to do to me?
It's gonna make it steeper.
It's going to make it more, it's going to go here now, right?
So before we start, the horizontal asymptote is just 0, right? So y equals 0, and then that -2 is going to throw us down 2 steps. So we're at.
Say it again.
So before we even, the horizontal asymptote is 0, so y equals 0, but that -2 is going to shoot us down. So we'll.
2 is going to make it steeper, right? Here, let's just do this. Let's just do, here, let me throw this in here. Let me back up here. We're in black really quickly. We're going to go -2 to the 3x power, right? xy. Okay? 0, 1, 2, -1, -2. 3 to the 0 power is 1. 1 times -2 is -2. Do you see that?
So the 3 has the 3 is in.
So 3 to the first power is 3 times -2, -6. 3 squared is 9, times 2 is -18. 3 to the -1 is 1/3, that becomes -2/3. 3 to the -2, -1/9, -2/9. Okay, so if I were to draw this here, I've just added a -2, I'm going to go to 0, 1, 2. 1, 2, 3, 4, 5, 6. I'm here. 2, 18, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm now clear down here. -1, 2/3. -2, 2/9. Okay, do you see this here? Okay, do you see what that's done? So that's just simply putting the -2 there, okay? So I still would normally So the negative is going to put me here, but then the 2 is going to multiply it, and so I'm going to go twice as far away.
Okay.
Okay? The asymptote, notice, didn't move
Yeah.
in that case.
Okay.
Okay? Does that make sense?
Yeah, so the -6 is what moves the asymptote.
So yeah, this is what moves your asymptote. Okay? All right, so we've got this, so we've taken care of this. Now the 4, okay, a +4 here, that's gonna move it, well, positive is gonna move it in the other direction. Really what we care about is the 5. What's 5 gonna do to me?
It's gonna move you to the left 5.
Move me to the left 5. Okay, so this point now is going to move 1, 2, 3, 4, 5, 5. So this point now moves clear over to here. The -6 is going to do what to me?
Down 6.
I'm going to go down 6. So 1, 2, 3, 4, 5, 6. So now here's my point. And this also moves the asymptote down 6. The asymptote was originally here. 1, 2, 3, 4, 5. Oh, sorry, I moved that 6. This is going to be 2 more. Okay? So the asymptote has moved 6. And now I've got to go 2 more here. Okay? So this is going, sorry, it's clear over here now. Okay? So this is going to look like this. Does that make sense? Oh, we're still on the board. It's a good one.
Okay, so so the -2, it flipped it, right?
So the -2 flipped it from the top to the bottom, and it doubled it.
Doubled it. Right. Oh yeah. 'cause-
Normally it would be
yeah,
here. If it was a 1, it would have been here. The 2 put it here.
Mhm. And then the 3 is just your base, right?
3 is your base.
And the 4x
4x is going to make it steeper.
is steeper, and then the 5 just moved it to the left,
5 moves it to the left 5.
and the -6 moved it down
Six
from
moved
the
it down.
-2. More
So it
than
moved the
negative.
asymptote down 6, and it moved your point here down 6 as well.
The -6 did that?
So the -6 moved both the asymptote and it moved this point down 6 as well.
That's a negative.
The starting point, pretty much.
Your starting point.
Okay. So yeah.
So that's why we're at
The
-8
asymptote's
rather
too
than
higher than
Mhm.
Can we do another problem that shows the effect the E value will have on the graph?
the E value.
Yeah.
Oh, that's section 4.2. Yes, we will.
All right.
We're just playing with regular whole numbers before we start throwing E's at you. Okay?
What the VIU?
I'm just talking about the number in front of the exponent x.
Like just that alone?
Yeah, how, if it's like a bigger number, how does it affect the whole curve of the graph? We covered whether it's positive or negative, but
So yeah, we didn't cover, yeah, we assumed that it was a whole number.
yeah.
What if it's a fraction?
Then you turn it into decimal.
1 over A. It's just going to change the steepness of it. Okay? So you can see here,
Can we get like a new graph going?
oh, actually, well, it depends on how many fractions of A.
Like it's like erase something, get a new graph.
Yeah, we really kind of need.
Graph is like a
something.
mess.
We're not on the board.
But I'll make
But you're talking about instead of having a -1.5 here, or put it at 1.5 there.
No.
But an E, that's a D, right?
On your original
That
example,
can't be comfortable.
What are you doing? Looks silly.
Okay.
on your original example with dA EX plus B plus C, I'm asking how the E affects.
The E just makes it steeper.
Okay. Then we're good.
Okay.
You good?
I'm good.
All right. And if it's a fraction, what does the fraction do to it?
It'll make,
It flips across the y-axis. Should we do one more of those?
Yeah.
Okay. Can I erase all this other stuff?
Yes.
so anytime there's a number in front of your base,
Oh, because it's the same as if.
It's the same as making it a -x.
So anytime there's a number in front of your base, that makes, or that will affect your points.
Okay,
Right.
so let's do one that's not quite so complicated. Function of x equals 1/3 to the x plus 3 minus 1. That's not so crazy, right?
No.
Okay, Sam, looks like you can do it.
I can't wait.
Okay, so what's our normal point? Normally we have an asymptote here,
Right.
and we have this point here.
Right.
So I will show the shifts in blue, okay?
So first thing first.
In fact, let me finish this. So this is the original unshifted, right? Unshifted. Shifted, okay? Now we're gonna shift it, so what does the 1/3 do to me?
So the 1/3.
Go mirror it.
It's gonna mirror it, right?
Yeah.
It's gonna mirror it across here. So now we're going here, okay? So that's my 1/3, okay? Now, what does my plus 3 do to me?
Plus 3 is going to shift it left 3.
1, 2, 3. So now this point becomes, so this point is now -3, 1, right?
And this is going to become.
And so we're
-3,
still
0.
here, correct?
Exact same graph, right?
Yeah, so I've just added the plus 3.
Right.
Now, purple, good thing I got 5 colors today. What does the -1 do to me?
Move it down 1.
It's gonna move it down 1. So now I'm here,
Your asymptote.
my asymptote has also moved down 1. And it looks just like this. Does that make sense?
So those numbers that you picked, or those numbers that you've drawn or underlined, they affect just your location of the graph.
Yeah.
The other ones.
Yeah, I tried to do it one step at a time.
Mhm.
So the 1/3 is the blue, it flips it across the x-axis. Plus 3 is the red, shifts it to the left 3. -1 shifts it down 1. Shifts the asymptote and the 0, 1 point. Okay? So this point has now shifted from 0, 1 to -3, 0.
More question. So then the D and the E, right here where you put it, those ones will affect the graph, like how it looks. They'll move the points around, right?
Correct.
And those ones just move the location of the graph. Okay.
Okay? There was a question. Who had the question? Was it Cameron?
You answered it.
I got it?
Yeah.
Okay? Do we want to do one more of those just for fun?
Which one flipped it on the y-axis there?
Okay, so if I had rewritten this, another way to rewrite it, I'm out of colors.
Oh.
So this purple graph here, I'll write it in
Next
purple.
-3.
I could have rewritten, this is exactly the same as 3 to the -x plus 3 minus 1.
Yeah.
That's exactly the same as the purple graph.
Yeah.
Does that make sense? Haley?
So just to clarify really fast, so when it says, on the equation where it says -1, you just move the asymptote down 1.
Asymptote's going to be, yeah, down 1. Okay? All right. You feeling good about that? Do I want to do one more just for fun?
Yeah, one more, a little bit slower though.
I have a request.
Slower? Okay.
Perfect.
I have a request.
Okay,
Could you
good.
just do the same fraction, just now include the D and the E? That makes sense?
Okay, make it up and then we'll do it.
Make one up?
Yeah.
Okay.
We'll make up the problem and we'll do it.
Okay, f of x
F of x equals
equals, let's say 3
3
times 1/3
times 1/3
to the power
You have a fraction.
of, let's say, of 2x
2x
plus 3
plus 3.
minus 1.
2x
Plus 3 is the
So the
exponent.
2x plus 3.
Oh, yeah,
Plus
2x, yeah,
3 is
2x plus 3
exponent.
up there, then minus 1.
Minus 1.
Yeah.
Okay?
I have a question really quick.
Okay.
So what if you had 1/3 to the negative x plus 3? Would that, how would that affect it? Because you have.
Okay, so you guys are doing a lot of funny things here. Let me just say this. How could I rewrite this so that I didn't have a fraction in it?
Just do 1 to the.
So an equivalent expression would be
3
3 to the third power
negative 2x.
negative 2x plus 3 minus 1. That's the exact same function.
I feel like the 1/3 one looks easier, because I hate negatives.
So.
Okay, but do you see that? Okay, these are the same equation.
So then you switch to 1/9. So you can't do the 3 times 1/3 and cancel it to be 1.
No.
Okay, because you have to do the exponent first.
Right. Because of our order of operations. Okay, so Marco,
Yeah.
you want the black one, right?
The what?
So you want the black equation, not
Oh,
the
of
purple
course.
equation, okay?
Question
So,
was that.
all right. So, which one? What? So normally, okay, here, let me draw this. I'll do this in blue. So the normal equation in blue is going to be this, correct?
Yes,
Okay? That's the normal exponential equation,
yes, sir.
okay? What does,
Wait, I thought we flipped.
this is unshifted on everything, okay? Now, I'm going to say, what does the 1/3 do to it?
Mirrors it,
It mirrors it,
about
okay?
the y-axis.
So so the 1/3 is going to mirror it. Okay? The 3 is going to do what? This
Which one?
3.
The 3 in front and 3 up, the next one.
This 3 is going to do what?
The 3 is gonna
It's gonna.
change your x value.
It's going to change this up. Instead of being 0, 1, it's going to be 0, 3, right?
Yes, because it was
So,
0, 3.
so this 3, it changes the steepness of the graph. It's going to get steeper a lot faster, and like it's going to look more like that. Okay?
So you just
What
multiply
does
that by the 1. So whatever number is there, you just multiply by the 1.
Yeah.
To get that.
And in your base, right? So say it would be like 2, what would be like 2, 6 or something like that?
Okay. Now, what does the 2? Let's worry about this one first. What does that +3 do to me?
The +3 will move you left 3.
It's going to move me left 3. 1, 2, 3. So this is now here,
Here.
right? Very
Same
steep,
graph.
something like that. Okay. What does the -1?
Moves the
Green.
starting point.
The
and your
-1 does
asymptote.
what?
It moves your starting point and your asymptote down.
Moves my asymptote down 1, and this is going to move down 1 as well. Okay. So I'm on the blue.
Yeah.
Except for I'm going to cross now. I don't know where I'm going to cross, but that's good enough. Okay? And then we need to worry about this too. What's that going to do?
Let's find out. E.
It's going to make it even steeper faster because think of it. If this is 3 to the x, 3 to the 2x is going to go even faster. So it's going to make it even steeper. We're going to have to go back to black, I guess. Okay?
Nice.
Back to black.
Back to black.
And here we go. It's going to make it even steeper.
So
Okay.
the 2 up there would just affect the values that you'll get when you get the 0 times
Yeah.
football, you know?
So this 3 is going to affect your location. You're going to multiply 0, 1 by here. But this 2 does not.
So say there was a 1.
They both make them steeper, but this is going to make it steeper faster than that. And that is also going to shift it from here to here. Does that make sense?
Is there a way to combine those and just, like after you're done, like with the 3, just combine them? And
Yeah, I
times
wouldn't
that?
worry too much about the 2, except for, just remember that this is exactly the same as that. This piece is exactly the same as that piece.
Could you like write down like our X and our Y's for this? That makes sense?
Our X and our Y's?
I think I'm seeing like it change, you know, like the X and Y's? Oh, okay.
Like a table. Like it's
The X and the Y table?
Yeah, you know, to see like how it changes from there.
Yeah, but it's going to get pretty complicated quickly.
Because of the 2 up there?
Yeah, and of course, you could always do the XY table, but at this point, I'm trying to avoid that. But realize that's always going to be there.
Okay.
Okay? Sam?
So when you shifted up 3, is that,
This shifted in blue, 3?
yeah.
No, that didn't shift it up 3,
No,
that shifted it left
the
3.
leading, the D,
The red?
yes.
The red 3?
Yeah.
Yeah, so all that did is multiply the 1 by 3.
Okay, so it's not moving it up from the origin.
No, it's
based
just-
off of that 0,
Right,
1.
yeah. So this does not affect your asymptote at all, but this one does. Okay? Ethan?
So, I don't know that when you change your equivalent third to 3, from negative to x,
Uh-huh.
you take x on the x from x to y to 0 and 3.
I can't hear.
So, on the second one, you put parentheses
So this is a complete
for,
question.
and the negative outside.
Say that right here.
Right.
Wouldn't that change the outside?
See how-
So why didn't you do it to the other?
So do you understand that 1/3 to the x power is the same thing as 3 to the minus x?
Yeah.
Say it like this.
That's why these two equations are exactly the same.
No, well, if you distribute that negative, doesn't it change the three?
So he's asking when it
Oh,
becomes
you're
negative two
right.
x minus 3.
So after you.
Oh, yeah, you're right. I should have written it like that.
Three
Yes.
times.
Now it's the same.
Well,
So it only affects.
So right here. Right here.
yeah, so it doesn't make the entire exponent negative?
Well, let me make sure. 1/3 to the 2x
There's a lot of
plus
steps.
3.
There's a lot of simple
and
steps, you know?
3 to the minus 2x plus 3. Let's prove that those are the same. Or not the same. Okay? X, Y, 0, 1, 2. That's hopefully good enough. So that's going to be 1/3. Let's see if I have a 0 here. 1/3 to the third power is going to be 1/27, right? Stick a 0 in for here. If I stick a 1 in here, that's 2 to the 5th. So that's 1/3. That's going to be 1, 2 plus 2 is 5. That's 1/3 to the 5th power. And this is 4 and 3 is 7. That's 1/3 to the 7th power. That's good enough for what I'm trying to do. Okay? Let's check this here. X, Y. 0, 1, 2. If I put a 0 in here, 3 to the 3rd power is 27. Oh, no, that's not the same, is it?
So we would have to distribute the negative.
It is distributed.
Right, and it would be to the minus 3, which would then be 1.7.
Say it again.
So, I mean, if we distributed the negative to be negative 2x minus 3, so when you plug in a 0 for x, you'll be left with a negative 3.
Oh, yeah, so I
Which
have
would then
it.
give us the same answer.
Yeah, so that's how it should be written.
Okay.
Yeah. So now, yeah, now it's the same. 0 power, negative 3, if that's positive, yeah, so now it's 127. So I did have it right. Yeah, that's the same thing. That's the same thing as this.
Well, so I guess what the question originally is, because we got the negative now on the outside of the exponent, does it change how we're shifting the graph? Because we could distribute it, and then it becomes negative 2x minus 3, would we then be shifting it to the right?
So 3 to the negative 2x minus 3. Is like shifted
Because
to
if
the
I were to
right.
glance at that, I would flip it over the y-axis, and then I would shift it to the right.
I think I have like good answer to that.
Okay,
So from that other equation we had, the plus b, or no, sorry, the e value can do the same thing that the a value does as far as flipping it, or, hold on, let me check just.
No, because the,
And then the minus 3.
because the a flips it over the y-axis, and the e flips it over the x-axis, right?
okay, assuming A is a whole number,
Or vice versa.
positive E is just gonna look like this, negative E is gonna look like that.
Right.
Okay? If A is not, if A is a fraction, then everything's reversed. Okay? All right. Now, the last thing that I want to do in section 4.1, 4.2 is short, so that's kind of nice. And it's more of the same. But there is this, and I actually was looking, I don't think I gave you very many good compound interest problems.
What?
I probably should add an extra. Okay. This is what we call the compound interest formula. And I think I only asked you one question on the homework. I might have to add a few more. Because this is something, I know, I used to teach at Salt Lake Community College and they really like these problems. And I didn't assign any here, and I don't know, I can't remember if UVU likes this problem or not. But just to be safe, I think I'm gonna add a few more problems for your homework. Compound interest, A of t equals P times 1 plus R over N to the NT power, okay? P equals your principal. R equals your interest rate. N equals the number of times compounded per year. And T equals the number.
I remember this. Yeah, I remember this.
I think I only gave you one problem, so I think I need to give you a few more of these. So,
Are we gonna need to memorize that formula?
Yes.
Is that provided?
I think you should memorize it. Yeah.
Miss Brown.
Correct.
No.
A of T.
Miss Rational gave us.
Okay, so find wait, here, let's do it this way. $1,000 is invested at 12% per year. That only happened in the 1980s. Our interest rates are a lot slower now. Find amount if compounded
Annually.
quarterly for 3 years. Okay? Marco,
Can I head up? Can I do
you
this
want
one?
to do this one?
Yeah, I got
Oh,
you.
you're all over it today,
So
man.
P is 1,000.
I've already picked on you plenty of times. But
No, I'm trying to learn.
Brent's just glad I'm not picking on her, right? Okay, so go ahead.
So the principal equals 1,000. And then you do 1 plus the rate, which will be 0.12, right?
0.12,
Over 4. That's
4
right?
because it's quarterly.
Then the exponent will be the 4 times 3.
3 years. Okay? But this is the kind of problem I could give you, and theoretically you could plug it into your calculator and you could get
I use my calculator.
1425.76. Okay?
What's the other one? Is it PERT, right?
That's what we're going to learn in the next section. Okay?
That's interesting.
All right, so the more times you compound it, the better for you. And better for the bank too, if they're loaning you the money. Okay? All right, so now, and I shouldn't have used the letter E when I was doing that, I wasn't thinking of that. But let's move on to 4.2, which is really just an extension of 4.1, but we're going to talk about the natural exponent.
Wait, so 4.2 is just
Okay.
exponent graphing.
It's going to be more of the same. It's going to be more exponential functions. Okay? So in this case, there is a letter E. You are all familiar with the number pi, correct?
3.14.
3.1414159278, I think.
All right,
Anyway,
sure.
that's close enough.
3.4 is good.
E is an irrational number, just like pi, and the answer is 2.71828. 2.172818. I can't remember. It goes on forever. Okay? It's found. Okay, if you take 1 plus 1 over n to the nth power, it equals that number there, 2.71828. Okay? And it's used a lot in higher math classes. Okay? So let me ask you this. What if I asked you to graph f of x equals e to the minus x?
Ain't gonna lie, I'm gonna do
I
that.
think it's time to pick on Ryan because I haven't picked on him for a long time. Do you know how to graph that?
Don't.
You know how to graph a regular exponential function. What are the two things you need to remember for, what if it was f of x equals 2 to the x? You start with 0, 1, right? Put an asymptote right here. Okay. Now we're going to do this one in green. Okay. What is the important point? It's still going to go through this same point. What is this negative going to do to me?
It's gonna hurt you.
Oh, I think you were on it and then you stopped.
I just don't remember.
Finish your thought. Flip it over the, it's gonna now, instead it's gonna go over here. Okay? And so now it's gonna look like this. Okay?
So it's the same thing, the
It's
E?
the exact same thing. E is just a special number. It's this number right here.
So you're trolling.
And it's like, I'm trolling you, it's like pi. I could do pi to the x power. But E, you've got a special e to the x key on your calculator. And this is going to lead to natural logarithms later. And so just treat it, 4.2 really is 4.1, except for we're saying, here's this new number that we're going to call a letter E. Yes?
So say it was like e to the x, it would be exact same as the
E to the
2.
x, yeah, actually this would be a graph of e to the x. Y equals e to the x. This is y equals e to the minus x.
So e
Oh,
is
except for, you know what? I flipped it the wrong way. How come you guys didn't stop me?
because you're a
I thought
teacher.
E was doing that.
Yeah, I trust you more than I trust
Supposed to go
myself.
that way. What would this be? What would this be here that I just drew?
That's negative.
That would be minus e to the minus x. Here, I'll do that in blue. Y equals minus e to the minus x.
So it was just.
This is e to the minus x.
Oh, it's going swoop.
What's it just be minus E?
E to the minus x. Okay? Yes.
Would you recommend investing in a non-graphing calculator for the next few chapters? We're going to be using E a lot.
We are going to be using E a lot.
Are we gonna be expected to graph exact points, or?
You are going to have, well,
We'll just
so
plug it in?
basically, here's the main thing. You're going to have to know how to shift this left, right, up, down, and to flip it. Okay? Are you going to need a calculator? Not yet. Graphic calculators are outlawed for this class.
They're
If
outlawed.
we're doing compound interest, I would.
Yeah, compound interest. We also can do continuous interest. Am I going to do that one? Yeah, they do. Okay. We also have continuous interest. Okay, and that's where this comes in. And I think Marco already gave us that formula. Read it to us again. A equals PERT, right? A equals P e to the RT. That's what we call continuous interest. Let's do this same problem, except for compounded. We're going to change this to continuously every second.
Second?
Yeah.
Wow.
Okay. To be honest, it's not that different than compounding daily. Okay.
I got you.
So we're going to do this. Okay, go ahead.
1,000
1,000
times e
e.
to the power of,
The rate was
the rate, what was it? 12, or 0.12.
12%. Oh, we can see that, right?
I thought it was 0.12%
0.12 to the,
to the
and times
rate.
how many years? 3 years. Okay. If we plug that in, I don't know the answer. Oh, do I? Oh, I do know the answer. It's $1,433.33. So the difference between quarterly is about $8. Less than $8.
So tell me that in this situation, I want to do continuously,
Yeah.
make more money.
If I would have done this daily, I would probably be off like 2 cents difference. Okay.
See, I like this. That's why it makes
You like
sense to
this?
me. Yeah. Until he's like, all right, next time we're going about.
Oh, you know what we haven't done?
So the hell's cute? Oh, a piece of music. It's a good song.
Here, let's just do this one really quick. I shouldn't do that one. Oh, this is one I didn't assign. This is a good one. Let's just make sure how good you guys are. This is problem number 15 in 4.2. H of x equals e to the x plus 1 minus 3.
Got that?
Okay? It must be, Jonathan, sorry. I want you to graph this. Okay, normally we would have this and we would have this, right? The plus 1 is going to shift it.
Nope.
Nope.
Wait, no, it's the plus one. To the left one.
To the left one,
And then
minus 3 is going to shift it
down.
down 1, 2, 3. It's also going to shift my asymptote down 3, correct?
Just.
And then it goes just like this, right? So that's h of x.
So wait, so that's a positive, what's it called, graph? It's a positive one? Come on,
That's
now
weird. I
refresh.
guess I've been on here for too long. Who thought I wasn't actually doing anything?
So that's a positive graph, and it was out, say like it was a negative e, would be going up all the way?
So what would a negative e, so if I had a negative e, you want this to be negative?
Yeah.
What would that be? What would that do to it?
It'll flip it
Flip it where?
The Y.
on the y-axis.
It would flip it over the asymptote.
Asymptote, yeah, right.
So it's going to flip it over the asymptote.
So
So
what,
that's going to be,
That's negative E or negative?
that's a negative,
So you can E, not that.
Negative E.
this is negative, right?
yes. So in what situation would you flip it over the y intercept?
Yeah, so if it's here, it's going to flip it over here.
The asymptote.
And if it's here, I'm running out of colors. Really glad I brought a lot of colors today. If it was here, so I'm going to ignore the red for a minute, what does that do to it?
Flip it across the y-axis.
Flips it across, now it flips it this way.
Or,
Now, if I did both the red and the purple, then it's going to flip it this way. Okay? All right. Gosh, I thought I was going to run out of time.
no, Jay was good, Jay. I came in, so it's negative down fast.
Okay, let me look at this really quickly. I would like you to do a couple of these interest problems. So here I will write this on the board. 4.1 add in addition to what I've already got assigned, and I know it's a lot. About 55 through 57. Sorry, it's actually, no, that's good. 55 through 57. That's good enough. I'm just gonna add 3 more problems on there, just to make sure you have plenty of those, okay? So quiz tomorrow is on 4.1 and 4.2.
Maybe any compound or per question on it?
Did I, oh, you know, I didn't see.
All the way down to the bottom.
Yeah, those are on there.
Okay.
Those are good. So yeah, just add these 3 problems on to 4.1. Okay? So see you all on tomorrow, Wednesday.